Okay. Today, you're going to have a very short assignment, but they are more challenging problems. We'll simply add on to the last assignment. Today we want to continue to identify indefinite integrals. This is 5.5 notes again, but this is part 2. Now we're going to see integrals are more challenging. And if we do what we did last week, you would most likely identify u to be what in this scenario? X squared plus 2, good for you. And then du would be equal to 2x dx. Now, what's different about this problem now that you do that? 2x is not x to the third, and we know that you can multiply by 1/2, so 1/2 du is equal to x dx. But we need an x cubed. We don't have an x cubed. That sounds like a good idea, to multiply both sides by x squared. The problem is that then you'll have an x with a u, and we can't have that. We have to substitute u to be a variable throughout. So I'm going to rewrite the integral just a little bit, see if this helps you see the answer. I'm going to separate that x cubed into x and x squared. So you can see that the x is used up here with the dx. I can substitute a 1/2 du. So we know that this part here will be 1/2 du. We know that this part here will be u to the 5th. We're wondering about this piece right here. That's what we have to, kind of substitute in order to complete our substitution. I'm waiting. If it was a snake, it'd bite you. Be the best of the best. Take a shot. So, Joe, okay, Sarah, you got an idea. I'm going to let you roll with it. Tell me more. You told me that. Say what you said. Right here, with the u. So I just want an x squared. So this is correct. All we have to do is look at this piece right here, and we come up with our x squared. X squared is, in fact, u minus 2. And that is what can go in for this piece right here. So I like to call this kind of a double substitution type problem. Let's look and see what we get. First of all, I have 1/2 du. And if it helps you, get rid of the stuff when you start substituting other stuff in so you can see what you have left. X squared is u minus 2 because x is taken care of by the 1/2 du. So now instead of x squared, I'll write u minus 2. U to the 5th. Some people actually try to start taking the antiderivative right now on the test. That would be a bad idea. Let's do 1/2 integral of u to the 6th minus 2 u to the 5th du. What is the antiderivative of u to the 6th? U to the 7th over 7, so multiplied by 1/2, we would have u to the 7th over 14. Minus 2u to the 5th, the antiderivative is. Yep, u to the 6 over 3 multiplied by 1/2 would be u to the 6th over 6 plus a constant. we substitute u back in, which is x squared plus 2. Oh, to the 6, thank you. And there we have it. Okay, let's try another one that's very similar. Okay, we'll try two that are a little bit different. 4x to the 5th, x to the 3rd minus 4 to the 3rd dx. So u is x to the 3rd minus 4. So du is 3x squared dx. I do not have a 3x squared. So what should I do? Divide by 3 and multiply by 4. So 4/3 du is equal to 4x squared dx. So if I divide by 3 and I multiply by 4, I get 4/3 du. And that's what we're going to see right here. If I rewrite this as the integral of 4x squared, and then the x to the 5th is x to the 3rd. I'm sorry, 4x squared times x to the 3rd will give me that 4x to the 5th. X cubed minus 4 to the 5th. Whoop, 3rd. Excuse me. If you rewrite it like that, you might more easily see your substitution. So 4/3 times my integral du. What can I get rid of now? 4x squared and dx. And yep, all of u to the 3rd. That gets rid of that guy right there. Yeah, x to the 3rd is u plus 4. No, but you have to distribute. So I have 4/3 times the integral of u to the 4th plus 4u cubed du. And I derivative of u to the 4th. U to the 5th over 5. So we're going to have 4u to the 5th over 15. We distribute our 4/3. And then the antiderivative of 4u cubed. U to the 4th. So 4u to the 4th over 3 plus a constant. And it looks like my substitution is x cubed minus 4. So 4 times x cubed minus 4. What do you think? Whoop, sorry. 2 times in a row. Next example is a problem I really like. And I like it a lot because when people make a substitution, they often see that they have two options. And the first option that people see is u is equal to, say, cotangent. What's the derivative of cotangent? Negative cosecant squared. Here's the problem. If we make that substitution, I don't have a cosecant squared. I have a cosecant to the 4th. Sometimes people choose u to be cosecant. And du is then equal to, what's the derivative of cosecant? Negative cosecant cotangent. And you see that you have a cotangent, but people don't feel that they have a cosecant. If I simply just play a small little trick here, and I just expand this a little bit, and I write it as cosecant cubed of x times cosecant of x cotangent of x, all of a sudden our substitution of u equal to cosecant is going to look much more attractive. So if u is cosecant of x, du, as we said, is negative cosecant times cotangent. Well, do we have a cosecant cotangent? We do. We don't have the negative, so we'll just divide that off. Negative du is then cosecant of x, cotangent of x, dx. My integral will have a negative sign out front, and a du. And again, if you get confused what that takes care of, then go ahead and start crossing stuff out. That is all gone. Instead of cosecant, I have u cubed. What is the antiderivative of u cubed? So I have negative u to the fourth over 4 plus c, and u is cosecant, so I have negative cosecant to the fourth of x divided by 4 plus a constant. That's my antiderivative. I won't comment on your selection of music today for the growl. I don't know, but I got sick to my stomach. So. Okay. All right. Well. All right. The last problem. This is all we'll do for today. So maybe we'll get through this before lunch. This is the most challenging of them that we have. So let's try to work through it together. I would say if you could do this type of integral problem for the test, you could get an A on this test. Okay, but this is a challenging one. I would plan on seeing something like this on the test. So u is equal to 3 minus x. So du is negative dx. Very good. Negative 1 dx. I don't have a negative 1 dx. I have a 3, right? So I'm going to multiply by a negative 3. Negative 3 du is equal to positive 3 dx. So if I write negative 3 integral du, what I could get rid of is the 3 and the dx. And here I have a 3 minus x, so I can put u in there, and I have u to the 1/4 power, right? But I need to come up with an x squared. And then square it. Yeah, so I've got x is 3 minus u. So if I square it, then I get going to have a u squared minus 6u plus 9. Yeah. Yep, that takes care of now my x squared. So now all the pieces are gone. So I have my substitution complete. Now, even though we have this antiderivative, and technically you guys know how to do it because we've done it before, you may have forgotten, but If I'm dividing by one term, I should just divide everything through by that term. So this is u squared, which is u to the 8/4. So it would be -3 times the integral of u to the 8/4 over u to the 1/4. Yes, is u to the 7/4. And then -6u to the 1, that would be -6u to the 4/4, which would be, yep. And then plus 9u to the -1/4 du. Everybody okay there? Okay, well, that's the challenging part. Now we just have to do some basic arithmetic, right? So let's take the antiderivative. We will add 1. U to the 11/4 divided by 11/4, or multiplied by 4/11, minus 6u to the 7/4 divided by 7/4, or multiplied by 4/7, 9u to the 3/4 divided by 3/4 and multiplied by 4/3 plus c. Okay, so now I'm going to distribute the -3 and I'm going to put u back in, and u is 3 minus x. So -33 times 3 minus x to the 11/4 over 4. Plus 24 times 3 is 72. 72 times 3 minus x. Oh, 4/11. Thank you. -12. Boy, I made 3 mistakes in this class now. All in one day. That's pretty bad. Yeah, let's just stop. All right, so I've got 72 times 3 minus x, so 7/4 over 7. And then the 3's are going to cancel, right? So it'll be a minus 36 times 3 minus x, so the 3/4 plus a constant. I don't know about you guys, but pretty unbelievable to think that if you took this derivative, you get that. That's unbelievable. Go get some brain food. You'll have time to work when you get back. Okay, my dear friend Caleb fails to see the assignment. He says, what is up with the super long assignment? This was your assignment from Friday. Okay. So please add on to that 5 problems. 5 problems. There you go. You have the rest of the time to work.